Okay, I'm going to take a slightly different approach to the problem, but similar. Um, I'm going to do what Wells would normally do, which is a U substitution in the problem. Before I do that, though, I want to point out I'm looking for something that's like a perfect square. So what I want to do is I want to look at this guy right over here, and I'm going to try to make it a perfect square. And this is a general pattern that Wells is presenting in his problem set. So I'd factor out x squared from that, and then what would you get? Let's be careful about this. You're going to get x squared, and then what do you get? You would get minus, let's see, 18x. And to complete the square net, you take half of the minus 18, which is 9, or minus 9 squared, you get 81. Now, if you realize if I did that, I'm adding 81x squared, so I have to take it away. So it's minus 81x squared. And all I did was that red thing. That's it. Now, you might say, oh, you made it worse. Maybe. It could be getting worse. Now, of course, when I do that, I want to do the other guy now. What's the other guy going to be? I'm going to write this down now. All right? The whole thing. So what do you write over there? Plus 109 x squared minus 252x plus 180 equals 0. I'm going to look at this guy over here, and I realize it's really a perfect square. All it is x, and then it's going to be x squared, and then x minus 9 squared. That's pretty simple. All right, now I'm going to do the next guy, and I'm looking at it, and someone says, what do you mean the next guy? I'm looking at this whole thing over here, and I'm going to write it down. And what do I see? I see, let's see, 19 and 9 is 28 minus 252x plus 180 equals 0. I want to claim what we're really looking to find, though. I'm looking to find something that looks more like that. And what I'm going to do is I'm going to concentrate on these two terms here, and I'm going to try to see if that works. If it doesn't, I'm in trouble. You get x squared, x minus 9 squared, plus 28 x minus 9. Well, 28, I'm sorry, I got to put an x there. I hope you agree that 28 times x is 28 x squared. I got to check this out. 28 times 9. And I'll write this on the side for you. That's 180. And 9 times 8 is 72. That's going to give you 252. It worked beautifully. All right? Now, someone says, why does it work beautifully? They're written to work. They really are. Let's keep moving. And what do you get over there? Plus 180 equals 0. I'm going to say this is u squared, with the understanding that u is equal to x minus 9. This would be 28u plus 180 equals 0. This is what's known as u substitution. You're going to hear that a lot in mathematics. They're going to take something that looks complicated and use a u substitution. All right, it happens all the time. They make a u substitution, make it simpler to look at. This is clearly simpler to look at. What do I see? U plus 10, u plus 18 equals 0. You get 28 in the middle, you certainly get 180. So you get u equals minus 10 or u equals minus 18. Now granted, you may think you're done. You're not done. You just found out what u is in the problem. So what I'm going to do is say, I think we know, at least know what u is. Let me erase all this business over here. I don't need it anymore. It's old stuff. I'm pretty clear that we were able to get to the u. All the distractions are gone now. My goal is to get x, though. So what do you have to do, which may seem very strange? I have to solve for x by substituting u into this equation over here. Let's write that down. Minus 10 equals x squared minus 9x. This would give me x squared minus 9x plus 10 equals 0. Well, I know that looks promising, but that's not going to factor using your finger numbers. I'll come back to that later then. Let's do the other one. What's that going to be? Minus 18 equals x squared minus 9x. Or I could write down x squared minus 9x plus 18 equals 0. This one's more promising. What do you get? X and x. I'm going to say 6 and 3 minus x equals 6 or x equals 3. All right? I want to go to the answer key, point out these things are staring at me right over here. I want to do the other one, more challenging. I got to use the quadratic formula. So what's x going to be equal to from the other one? We're doing this one now. X equals, well, I like to do the bottom first. That's twice a, which is 2. The opposite of b is 9, plus or minus. It's always this radical that I have trouble with. The radicand is going to be 4ac. I'm sorry, I misspoke. It's going to be the b squared, which is 81, minus 4ac, which is 40. So what do you get over there? You get 41. Not much I can do about that. By the way, that doesn't look like 41. Let me erase it and put 41 down. Let me get my red pen out and put this over here. Now, granted, I realize people look at my key and say, your key looks a little bit different than what you did over here. I want to show you there's variation in work, and there really is, all right? So I want to talk about one thing that you should be aware that your teachers are giving you problems that represent a pattern that they want to present to you. And Wells does the same thing, by the way. So I'm going to say over here is if your teacher is doing problems like this, you know when you get to the exam, you're going to be doing something like this, all right? Maybe not the exact same problem, but something like this. That's why it's so important to study what the teacher is asking you to do, all right? So important to do that. Now, granted, if your teacher's expecting little of you, they might be giving you very simple problems, and that's where you probably should look outside what school is doing for you and looking at other problems. And Wells is an excellent textbook to look at. I mean, he really does have some really nice problems. Anyway, you may want to reach out to me. My name is Ron Bannon. My email address is Bannon, B as in boy, the @ NNON.US. What am I particularly interested in? Hearing from people that see errors in the document and want to help me, all right? How do they help me? They tell me there's an error. They tell me where the error is, and I correct it, and I give them credit for it. Thank you so much.